Hello everyone. So in this session we are going to discuss about an important concept called debugging and how to use the GDB on C programs. So I'll be giving these sessions in a different parts where I will be introducing the basic level concepts to the advanced level concepts. So in this particular session I'm discussing only about the basic topics that I can use, how to use GDB to interact with a program and how to inspect the variables, how to inspect the memory location and rest of the things. So let me walk you through the topics that I'm going to discuss today. So I'll be discussing the basics of GDB, like how do you interact with the GDB, how do you keep the breakpoints, how do you move from one statement to another statements, and how do you interact with a running program. And next I'll be discussing how to compile the program with the debug symbol so that you can use it in the GDB. And we'll be seeing what are the different variables are located, how these variables are located, at what place it is located, what is the memory locations for the respective variables, how do you access this memory locations, and if you're having an array, how do you use the pointers in the GDB to traverse from one particular location to another location inside the array. And we'll see that how to handle multiple files when we are working with GDB. And finally we'll see a small piece of concept on the thread level and see that how we can use it to debug the threads. So let's get started with this thing, and let's move on to my terminal where I can show you the actual program of how these things will be working. So this is a sample thing that is present, and let me create a program for you. So this will be main.c. It will be very simple program which just contains 2 or 3 variables, and then it tells that what is happening with the variables in the GDB level when we are inspecting with the GDB. So I'm just creating a C program where I have int a is equal to 10, b is equal to 20, and let me put these 2 variables for now, and I'll be typing the command printf a colon %d comma b colon %d backslash n. I'm just printing the values of a command. That's it. Nothing much in this program. I'm just doing a simple variable creation, and then I'm printing the values. So let me write a makefile for this also. I'm creating a makefile, all $cc demo.c demo.c main.c -o sample. So this is the program I'm creating, and let me create the clean also, rm-rf sample. Okay. Now, in order to work with GDB, you need to have a debug symbols that are present in your output binary. Otherwise, the GDB will not be able to give you proper messages like what is this particular function, what is present at this location, or what is happening with this particular thing. It will not be able to generate that info. So in order to work with that particular information, you need to create the debug symbols. So the very first thing that I would like to tell is how do you compile the program with the debug symbols. So when you are using the GCC, there is a flag called -g, which you can give to tell to the compiler that include the debug symbols. Now when I'm typing, when I'm saving and exiting and I'm typing the make command, the sample is created, and if I'm executing the sample, you can see that the values are 10 and 20, right? Now let's launch this program in the GDB and see that how we can inspect the memory locations. So I'm typing the command GDB sample. When I'm giving the GDB along with the program name, it launches the program in the GDB environment, and then it will attach the debugger for that particular program, and it starts from the main function. So when I hit enter, you can see that it read all the symbols from the sample program that I have created just now, and it is ready to interact with that particular program. So the first command that we would like to know is how do we set the breakpoint, and what is a breakpoint? So when the program execution is starting from here, that is a main function, the next thing that will get executed is to create these 2 variables and initialize the values for these variables. And when this particular thing is done, it moves on to the next line called printf, and then it executes this particular statement. And finally, the return value will get executed, and then the program goes out of the scope, and then it exits. So it is a sequence of steps that happens in the program, and always your program will start from the main function. Now, how do we tell to the GDB that come and stop at this location so that I can inspect something? Inspect something means you can inspect either variable or function, what is happening, what is the return that is coming out of the function, anything you can inspect them. But I want to tell to the GDB that yes, come and stop at this location. This we call as a breakpoint. So in the normal program execution, you break at some point, and from that point onwards, inspect the either the variables that are present at that location or any of the further steps that happens with the interaction from the GDB. So since this location number is present at line number 5, I'm telling to the breakpoint in the GDB to keep it breakpoint at line number 5. So you can see that I have created a breakpoint at line number 5, and now the GDB is able to catch that breakpoint. So when I'm typing info breakpoints, you can see that what are all the different breakpoints that are present for this particular binary. Now the program is not yet started. So if I want to start the program and then continue the execution and then continue to execute till my first breakpoint is met here, I would like to tell to the GDB that go and start the execution. So in order to do that, type a command called R, which runs the program, and then it executes this program. And now since the breakpoint is met at this particular thing, it stopped at this location. So you can see that the first breakpoint is met and the printf statement is halted here. So this statement is not executed. It is just the compiler, the execution has came up to that location, and now it is waiting for the command from the user telling that what should I do next. So what we'll do now is that we'll go ahead and inspect this two variables before we move on to the next thing. So the very first thing that I would like to show is how do we access this variable. Accessing of these variables is pretty simple. You can use the print command and give the variable name. It just prints the value of the variable. Similarly, give b, it gives the value of b value. And if you want to know that where this variable is located in my memory, so I can type print ampersand a, which prints the memory location of a, and similarly print ampersand b, it prints the memory location of b, right? So now you're able to see that how these two variables are located in the memory, and then how what are the different values that are located in these variables. Now if you want to see what is the size of my variable, you can type the command print size of a and print size of b. So since my variables are integer variables, the sizes that are created on my laptop is 4 bytes. So I can see different variable sizes here. So print size of character, print size of short, print size of integer, print size of long, print size of float, and double. Okay, so this is the way of how to print the sizes of different data types. You can even use this thing to print the size of a structure or any other thing. Even the size of array also you will be able to print it. So since we see that how to access the variable address and how do we access the variable values, now let's do a different thing. How can I access this thing via a pointer? That means I'll not go to the program again, create a pointer and then come back. But instead of that, I'll be creating a pointer in the GDB environment. So I'm defining a variable called $setTemp is equal to, observe the notation what I'm doing here. So since I know that this is the integer pointer, I'm just creating the integer pointer and ampersand of a. Okay, this is telling that I'm going to create an integer pointer variable. And similarly, I'm creating another variable called temp2 and int star ampersand b. Now I created two variables here. So when I print $temp and print print a and print $temp, and similarly print $b, my mistake, print ampersand b and print $temp2. Now you can see that when the variable a, the address of the variable a is created, it is located at dd78. Similarly, temp is also pointing to dd78, b is located at dd7c, and temp2 is also pointed to dd7c. Correct? Now instead of using the variables a and b, I'll be using these pointers to print the data. So how should I print the data is print int star $temp1. This will create the variable a. This will print the variable a using the pointer type. Similarly, I'm giving the value called temp2 and then it will be printing the b value. So now I am able to print these values, right? So since my breakpoint is present here, I'm able to inspect all the things which are present at this memory locations, and then I'll be able to print this thing. Now I have done so many interactions with the GDB, right? So when you're interacting with this much amount, naturally you'll forget that where you are located. I mean, imagine a very big program that you are debugging, it's not easy to remember each and every position, and then you need to go back and front to see what are the different things where I'm present and these kind of things. So instead of that, you can run a command called backtrace, and then it will print this location of where you are currently and from which particular position you are currently inspecting. And then you can type info breakpoints to see all the list of breakpoints that are present, right? So currently I'm at line number 5. That means in the main program, I'm present at this line and I'm currently stopped at this particular location. Now, since the breakpoint is done and I have inspected all the variables, I want to move on to the next line. So in order to move to the next line and execute the next line, I'll issue a command called n, and then it moves to the next line. So now you can see that this command is executed, the printf statement is executed, and it prints the values. So a:10 and b:20. Now the execution has stopped at return 0, right? So if I press next, program has reached the end, and if I press next again, and the program has ended, and then it has exited normally, right? So when I hit next, now the program is not even being run. So you cannot run anything, and then finally you want to quit the GDB. So when you type the command called Q, you'll be exiting from the GDB, right? So this is a very basic program which tells it how do you use the GDB to inspect the memory locations. Now let's take it to a little bit next level. What we do is, since we know how to access these things, let's create an array. So I'll be creating an array called myArr, and I'll be creating an array of size 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so now I created an array of 10 variables, right? So once the array of 10 variables are created, what I'll do now is that I'll just compile this program again, and then I'll try to inspect this array. Okay, so let me clear the screen, and then I'm giving the make command. Now the entire file is compiled with the debug symbols, and I can run GDB to launch this program. So sample GDB. Now again the symbols are loaded, and this time I can keep the breakpoint at line number 6 so that the variables and also the array will get loaded. So I'm just going to keep the breakpoint at line number 6 so that now the breakpoint is present at this location. So I'm hitting R to start the program. It has created the two variables A and B, and also my array is created. Now let's go and see that whether these variables are already existing or not. So print A, yes, 10 is there. Print B, 20 is there. Print myArr, your array is there, right? Now if I want to inspect the array index by index, I can give like this: print myArr of 0. It prints the array by index locations. 1, 2, this is the second index, third index, fourth index, fifth index, sixth index location, 7, 8, and 9, right? Starting from 0 index onwards, I am coming up to the 9th index, and then I'm printing the values. Now, so just before this example, we saw that we created a pointer, and using that pointer, we have access to these locations, right? Now, this time I'll show you a little bit different. What I'll do is, since all the data types I have created as an integers only, let's do a little different experiment to see that how can I access all these things. So if I want to access all these things, first of all, I should know that whether my memory locations are contiguous enough to do that operation. So what I'll do is I'll type print &a to print the address of A, and print address of B, and print address of myArr. Now observe carefully what is happening here. So it is present at 8, right? 9, 10, A, B. So after that C will be coming. So it is presented here. Now C, D, E, F, and 0 location is present here. So it is present in the contiguous locations, right? So what I can do is I can point to the variable A, and then I can increment the pointers to traverse between this memory location, and this memory locations. So let me create such variable and try to traverse it. So I'll be creating the pointer variable again, $temp is equal to int star and ampersand of A. So I try to create the pointer variable for this particular A value. Now the pointer variable is created, and I can simply see where that is present. So print $temp, and it is pointing to address location 48 and 48, right? Now let me try to access the data. So if I'm typing the command print star int star of $temp, you can see that I'm accessing the value 10. Now how can I use the same variable to use the pointer arithmetic to increase the memory location and retrieve the next value, next contiguous. So what I'm doing is I'm giving the command called +1 and I'm printing the value of b, right? Agreed? And if I'm removing this thing, you can see what is the address value that it prints. So I'm shifting from 48 to 4c. Now similarly, if I want to shift to the array location and then print that, what I'm supposed to do, give 2, then it will shift to the array's first index, the 0 index. So if I want to print the data now, what I'll do here is I'll just put star int star and then give this, it prints the address of a, the array value, the first 0th index will be printed, correct? Now if I'm printing the value 3, it prints the array second location that is present in the array, and then the next one, and then the next one, and so on, right? So now you can see that how the memory is located in the contiguous parts of your program, and also see that whether these particular things are being accessed properly or not, or whether these are located properly or not, also you can verify with the GDB, right? So using these things, you'll be able to access any memory locations that is present in your program and see that whether the memory layouts and all these things are correctly set, whether the variables are in the correct position or not, or whether the intended values are going or not, you'll be able to identify it. Now let me run this program normally, because I don't want to inspect it anymore. So that what I'll do is I'll hit the command called C, so that it continues the execution and then it exits normal, right? So the program has exited. So what we have learned so far is that how to compile the program, how to access the variables, how to access the memory locations, and how to traverse the array using the memory location concept. Now let's take it to a next level where we will use multiple files and see that how do we interact with multiple files. That means in the real time, when you're working with the real time programs, your program, all programs cannot be in this simple thing, right? So basically you'll be having multiple files where you'll be doing some kind of logic separations, modularization, so many such things will be present. So let's take such a similar program to see that how do we interact with such a program to switch between one particular file to another file. So I'm just modifying this file a little bit. So I'm creating add.h, and I'm just creating one function in this, int addition of int a comma int b. So I'm just creating a prototype for this function, and I'm going to copy this function prototype, type add.c hash include add.h here, and then define the function. So return a plus b. So instead of giving return a plus b, let's create a variable here. Result is equal to a plus b. Now note that I'm giving the same variables, right? Even in the main program it is ab, and in the function, in the separate file also it is ab only. Now let's see that how do we differentiate this thing when we are using with the GDB. So return result, right? So this thing is done, and I'll be opening my main.c file, and since I print my values here, I'll be creating one more variable, int c is equal to 0, and then c is equal to addition of a comma b. And what I'll do here is hash include add.h, right? Let's compile this program. I need to add this thing, the program, right? So add.c, and then make it. Now you can see that the file is compiled. So when I'm running sample, just to be sure that this is coming from this thing only, let me open add.c here, and then just print a statement so that we are sure that, okay, yes, the program is executing from this file only. So program executing from add.c file. So I'm just writing here and make it. So since I need to include stdio.h, make it, and then run it. So when you run it, so program is executing from add.c, and then a and b values are added. So okay, I forgot to print the result here. So printf result %d \n, c. Now when I'm typing make, so a and b values are done. It is executing from add.c file, and then the result is printed here, right? Now let's see how do we traverse this kind of multiple programs. So I'm just putting the GDB here and then calling sample. Now imagine I want to break at line number 8, right? So when I want to break at line number 8 here, I'll be giving the command called b and then 8. That will be creating a breakpoint at this particular line. But if I'm creating the same breakpoint here, it is written from the function, right? So from here, the function execution is done and then it is written here. And if I'm creating a b5, that means I want to create at this location, but it actually creates at this location. So how do I solve this thing? So in GDB, we actually can create the breakpoints depending on the file names also. So I'm going to show you the way of how to create these breakpoints in this particular thing. So I'm going to create a breakpoint in the line number 5 in the function addition, which is present in add.c. So in order to tell that, what I'll do is I'll be calling add.c colon 5. That means I'm creating a breakpoint in the file called add.c at line number 5. That's the definition of this thing. So similarly, if I want to create a breakpoint at line number 12 in the main.c, so I can just tell that b main.c colon 12. Either I can just give b12 that automatically creates in the main file, or else I can create main.c colon 12. So I have created 2 breakpoints. Correct? Now let's see that I have created 2 breakpoints. Let me go ahead and create another breakpoint at this line number 8. So I'm creating b8. So you can see you are able to see all the 3 types of 3 methods of doing this, right? So here I'm giving the file name called add.c with the line number. Here I'm giving main.c with line number, and I'm not giving anything. So by default, it creates on the main program. So I've created total 3 breakpoints. Now when I'm typing the command called info breakpoints, you can see that there are total 3 breakpoints that are present. First one is created at add.c in line number 5, second at main.c at line number 12, and third one at main.c at line number 8. Now, if I hit R, that means if I'm starting the program, which breakpoint will first get executed? It doesn't mean that the breakpoint that I've created at the first in add.c, that is not the breakpoint that will get first executed. So you need to understand like how these breakpoints will be working. So it starts from this main function. It starts at line number 5, then it goes to line number 6, then goes to line number 7, 8, 10. From 10, it goes to the execution of this one. It goes to the next line and 5 here, and then it returns from this function. It again comes back to here. That means to store the value in C, and then it comes to this statement. It then comes to this statement, and then it executes the program. It exits the program. Now let's see that if this is actually the thing that is happening in the normal execution of it. So in order to tell that, I've created the first breakpoint here at the line number 5, but this is not the breakpoint that is going to first execute. The third breakpoint that I've created at line number 8 is the first one that is going to execute, because this is a sequence of execution, right? Now let's go ahead R and see what will happen. So when I'm typing R, you can see that the breakpoint is triggered at 3. That is a third breakpoint got triggered first at line number 8. So by the time it reaches line number 8, right, all these 3 variables are already initialized. A, B, C, and my array is also initialized. So you can just go ahead and inspect that thing. Print A. So the A value is printed. Print B. B value is printed. Print C. C value, nothing is there, like the result is 0. So nothing is present. And print my array. So the array is also present. Correct? So similarly, you can see print address of A, which is located at D44, and then B, which is present at D48, C is present at 4C, and my array starts at DD50. So these are the memory locations in which the program has created, and it has stored the variables. Correct? So this is a way of how to use multiple files and how to create the breakpoints in multiple files. Now, what I'll show you in this other part is, you don't need to create the breakpoint in this function itself. You can create the breakpoint here, and from this breakpoint, you can tell GDB to inspect this line by line. So how do we do that particular thing is, I'm just continuing this program and exiting it. So it continues the program, and then it exits, and then it exited normally, right? Okay. So coming back to the program now, how do we keep the breakpoint here, but we make sure that we inspect this line by line? That's the task that we want to perform. So in order to do that, let's launch the program and put a breakpoint at line number 8. So GDB sample. I'm creating the line number breakpoint at line number 8, and I'm starting the program. So the program is started, it is present at line number 8, and I'm currently present at this location. Okay, now once this location is present, when I'm hitting next command, it read the values of it print the values of 10 and 20 onto the std out, and then it came to this location. Now from here, if I'm pressing next, what is the meaning of next is complete the execution of this statement and then move on to here. But instead of that, if I am detecting that this is a function, and if I want to inspect the internals of the function, I can use the command called step. So whenever I'm using command called step, the execution will move to inside the function, and whatever is the first statement that is present inside the function, it will stop at that location, and then it will give you the chance to inspect from that point onwards. So when I'm typing the step command, the execution will move to the addition function, and then this stops at this location. Now let's see that how it will happen. So instead of pressing N, I'll be pressing the command called S, which will be invoking the step. So I'm going into the step command into the addition function, which is at add.c at line number 4, and currently it stopped at this particular location. So if I'm typing print result is equal to 0, right? Now when I'm pressing N, so the program is executing from add.c, which is present at this location. Now you remember that there are no breakpoints, right? And if you want to confirm that, you type info breakpoints to see that there is only one breakpoint which is present in main.c. I haven't kept any breakpoints in the function that is in the separate file. So currently my program is stopped at here. So when I'm hitting next, it is stopped at result is equal to a plus b. So print a, it just going to see that what is the value that is coming to this particular function. Print b, what is the second parameter that is coming to this particular function, and both of those things are getting added in the result. Print result, and then the value is 30, right? Now when I hit next, you can see that the function is exiting from here, and then it returns the control back to the main function. So when I hit next, it comes back to the main one, where the storing of the value that is returning from the result of addition of two variables a and b in the function addition is already completed, and the program has stopped at this location. So this is the location at which it is currently present, and if I print c, you can see that the value is 30. Correct? Now I'm just pressing continue C so that it can just come, it will complete the entire process execution, and then it exits the program. So this is how you'll be able to step into the function without even keeping the breakpoints at this location. So till now, what things we saw is that we created a program or a set of files which can be enabled, for which the debug symbols can be enabled. And once the debug symbols are enabled, we saw it how to control this execution line by line, how to inspect the variables, how to inspect the memory locations, and all these things. Now let's play a different thing of how to change the values in the memory location. So let's say, for example, we have this entire code, right? So the value of a and b are 10 and 20, which are fixed here. But what if I want to see that how these variables will behave? I mean, how my function will behave if I'm giving different values. So every time changing this thing, compiling this thing, in the normal way of execution, what I should do? I should change these values as 20, 30 or 30, 40 or whatever the values. And then I should compile this program, and then I should run the program to see that what output I'm getting, correct? But instead of that, we can use GDB to change the values at runtime, and then we can analyze how our program is behaving. So we'll see that particular scenario. Now, in order to do this thing, what I'm doing is I'm again using the breakpoint at line number 8 in order to achieve this functionality. So what I'm doing is I'm running the GDB command sample again. Now it is present at this location, and I'm creating a breakpoint at 8, and then I have already created a breakpoint, and I'm running the program. Now it is present at this location, correct? Now when I'm pressing next, this program will be printing 10 and 20 on the screen, right? But instead of that, what I want is that I want to change these variables altogether. That means instead of 10 and 20, I want to add 100 and 200. So let's say I want to change these variables, and then I want to make sure that how my program is behaving. So in order to do that, what is the command that I can use here is, if you remember, I was creating a variable called temp, right? Which is used to create a pointer variable and then point to the location. Similarly, you'll be using a method called set variable. That means now you are setting the value of the variable. A is equal to 100. That means you are setting the value of a is equal to 100. which was previously 10. Set variable b is equal to 200. Now you have altered both the variables, right? Now I want to see that whether what is the values that are currently residing in these variables. So I'll be giving the command called print a. You can see that a is 100 and print b is 200. Now if you remember the backtrace command, you can still see that the breakpoint is currently at line number 8 and my execution halted here. Now previously when I press the next command here, what was the output I was getting? I was getting a colon 10 and b colon 20. But this time, see what will be the output. So when I hit next, the a and b values are 100 and 200. Correct? So the program is telling that, okay, the memory locations which are present for a and b, I have inserted new data into that memory locations, and currently I'm executing the program with the new data. So when I hit next here, we can see that the result is coming, and when I hit next, the result is 300. So instead of adding 10 and 20, it is performing the addition of 100 and 200. See how am I able to change the values in real time and see that how my program is behaving. Right? So similarly, if I want to do anything, let's say I'll continue this program and I'll exit this. I'll again launch this program, and again I'm putting the breakpoint at line number 8 and I'm running the program. This time what I want to do is I want to give the negative values and see that how it is behaving. So I'll be giving first I'll print the values, print a, print b, and now I'm setting the variables. Set variable a is equal to minus 200, set variable b is equal to minus 300. So both the variables are now negative. Now let's see that how my program will behave for this addition. So I'm printing the value of a, which is minus 200, and printing the value of b, which is obviously it is minus 300. Now when I'm continuing the program, you can see that the result is minus 500. Correct? So this way I'll be able to alter the variables, alter the values in the variables in real time, and I can see that how my program will behave if I'm giving a separate variable, and how my program, I can even inspect that, okay, whether my program is stable enough to handle different kind of data type, different kind of data values, and all those things also I'll be able to find it. So this is how you can alter the variable data and make sure that how your program is safe against changing this kind of things. Now let's move on to the next one. Since we have covered all of these particular things here, let's move on to the last concept of threads here. So in order to do this threads, I'll be altering this program a little bit. So I'm including, obviously I'll be needing pthread.h, and I'll be requiring a thread variable, and I need to detach the thread. So I'm creating a thread attribute. So I'll be initializing the thread attribute. And let's say I'm launching the thread before this. So launch the thread here. So basically pthread underscore attr underscore set detach state. So what I'm doing is I'm trying to set it as a detachable. attr comma pthread underscore create detached. Right. Now I'm creating the thread itself. Ampersand tid, ampersand attr, and I need to create a function for this. So what is the thread function that will execute? So what I'll do is I'll quickly need to add the support for the sleep method. So let me create the thread function here, void star run my thread of void star null. So I'm just creating a thread program, nothing much here. So I'm just going to call this thing here, run my thread and null. Okay, so let me create a small infinite loop so that I'll sleep for every 2 seconds, or else even better, I'll sleep for every 1 second, and just I'll type inside thread. Okay, similarly, since this thread is launched and detached, the main function will not wait here, because the main this is not a join mode of thread. This will be continuously executing, and then the main function will also continuously execute. So in order to prevent that from happening, I'm writing one more main function, one more while loop here, infinite while loop. I'll type printf This is main thread, and I'm sleeping this thread for every 3 seconds. Let's say I'm doing it for 3 seconds. So just to make this a little bit interesting, I'm just putting int I is equal to 0, and I'm printing that how many times I'm executing this I plus plus. Similarly, let me create another value here, so which will be j is equal to 0, and I'm typing $d, comma j plus plus. Okay, and since I'm already implementing here and here, I think this should be sufficient. Now let me make this. I need to alter the make file to integrate LP thread, so that this thing will be started and then make it right. Now the program is compiled and the file is generated, the binary is generated. So let me go and start this program and see that how it is behaving. So both the threads are started. The main thread is sleeping, and it's hung up actually, right? So this is a thread that is printing the 0, 1, and 2, and 3. Am I using any scanf here? No. Then why this is happening? Why this is hanging up? Okay. So it is running. So the inside thread is running for every second, but the main thread is running for every 3 seconds. That's why you can see here that 3 times this is executing and this is executing 3 times. And for every third time, the main thread is executing. This is how the program is running. Now let's inspect how do we do and how do we know that, okay, how many threads are present in the program and how do we inspect the threads. Okay, so let's start the GDB again with sample, and this time what I'll do is, just to make sure that if I would like to tell that how many threads are present, first I would break it this particular line, and then I will break it this line, so that we can see that how the threads creation and how these things will happen. Okay, so the first breakpoint that I'll set it line number 24, so B24. Let me clear this. So I'm deleting the breakpoint 25. Okay, so let me put it breakpoint number 24. Got it? So the breakpoint is kept at line number 24, and the other breakpoint it is at line number 27. So let me delete this breakpoint at line number 27. Okay, this is also done. Info breakpoints. So there is a 27 line it is present. So clear breakpoints. Let me delete breakpoints. All the breakpoints are deleted. Info breakpoints. No breakpoints are present. Let me start it fresh. So I'm putting the breakpoint at line number 24. B24. This is the first breakpoint I've created, and the second breakpoint I'll be creating at 30. So B30. Right. So 2 breakpoints are created. Info breakpoints. I can see that the first breakpoint is present at line number 24 and 30. Okay. Now let's start the program. That is R. The program is running and it has stopped at this location. Now you can see that the program is executing here one by one, and it stopped it till this location. So till this location, there is no separate thread that is created, right? We are not creating and we are not running this thread. So when I'm typing info threads, you can know that there is only one thread that is present, that is a main thread. Correct? Now similarly, if I want to go to the next breakpoint, which is present at line number 32, so the second is present at line number 30. So if I'm coming to this particular line by pressing C, now the next breakpoint has hit and now it stopped at line number 30. Type the command info threads again. Now you can see that there are 2 threads that are present. One is a main function and another is this thread. Okay. So if I want to keep the breakpoint in the thread function here, since this is present in the same file, I can directly use the breakpoint B10 so that I can put the breakpoint at this location. Otherwise, I can even give like this. Either I can give B10 or else B main.c colon 10. Both are same, right? So it's set at the line number 10 at this location. Now when I'm hitting C, you can see that the breakpoint has hit at inside the thread at this particular line that I have set it here. Correct? Now I'm typing info threads, and now you can see that automatically the context has switched from the thread 1 to thread 2. Right? So the breakpoint is currently in run my thread, and then it is currently present at this location. So I can just continue to debug this thread here, respective of the main thread that will be continuously running for every 3 seconds. And if I'm running this thing, automatically this thing will be selected and the breakpoints will exhibit here. So let me show you how this thing will happen. So I'm hitting next. So sleep 1 is executing. Next, the main thread is sleeping. See, the main thread 2 has came right. Now it is again inside the thread. When I'm typing n, the thread is created. That inside the thread printf is executed and it is sleeping one time. So now the main thread is at 4. Now, if I want to inspect this variable I, all I need to do is print I, and then it prints the main thread. Sorry, the thread which is present in the run my thread, it will print the correct. Now, if I want to switch to the main thread, that means currently if I'm typing info threads, I'm present in the thread number 2. So if I want to switch to thread number 1, how should I do it is, I'll be typing the command called thread1 and I'll be switching to the main thread. So if I'm typing info threads, you know that now I'm switching to the thread 1. Again, if I want to switch back to thread 2, I'll type T2 and info breakpoints. So if I want to delete all these breakpoints and then create a new breakpoint at line number 36, then what I would like to do is delete breakpoints, delete all the breakpoints, switch to thread number 2. I am now in the thread number 2 where currently the execution stopped at this location, and now I'm creating a new breakpoint at thread number 36. So B36 and then C, continue. Now when I'm hitting continue, what happens is that now the breakpoint which is set in the main function is triggered. So if I'm giving info threads, you can see that now the breakpoint is triggered in the thread number 1, right? So if I'm typing print J, it will print that this particular function has executed already 5 times, right? So this is a way of how to switch between the threads, one thread to another thread, and how to make sure that the threads are, you are inspecting even at the thread level also. So using this mechanism, if you have multiple threads running and if a common variable is being shared across multiple variables, and sometimes you go into race conditions or else sometimes you go into a deadlock and this kind of situations, using this method you will be able to easily identify that which thread is causing that issue, or else the main thread is causing the issue, or some kind of subthreads are causing the issue. All of these things you'll be able to inspect the particular program at the runtime and see that what is happening. Now we'll finish this session with a small extra thing that let me go ahead and do this thing. So I'm again typing info breakpoints. So already you have a breakpoint at this main line number 36, right? So let me go ahead and create a couple of breakpoints. So what I'll do is I'll be creating the breakpoint at line number 10. So this is one breakpoint created, and I'll be creating one more breakpoint at line number 22. And I'll be creating one more breakpoint at line number 30. And I'll be creating one more breakpoint at line number 5 in the add.c file. So basically I'll be giving add.c colon 5, right? So info breakpoints. So now you can see that how many total breakpoints are there. So total 1, 2, 3, 4, 5 breakpoints are there, right? Now, sometimes when you're doing this thing, when you're trying to debug some kind of program, which is recurrently you want to see the executing things and other things, it would be better if you can save all these breakpoints, right? That means if you can save all these breakpoints into a file which you can load it at runtime, then it will be pretty easy to manage these breakpoints also. Not every time, let's say you create some 30-40 breakpoints, every time launching the program and creating that by hand is a troublesome thing. So instead of that, you can save this entire breakpoint as a snapshot and then you can load it back. So in order to do that, the command that you use is save breakpoints into a file called sample underscore b breakpoints.gdb. So it is telling that it is saved to a particular file called this thing, right? Now let's go to your program where the program is residing. You will be able to see these breakpoints, correct? Now let's open this breakpoints with a VM editor and see what is present inside them. It tells that you break at this location at this particular number. You break at this location at this particular number. It's a set of commands that is being given, right? Now when I'm quitting this program, so once you run the program, let me load this thing. So basically all you have saved in the sample underscore breakpoints.gdb. Now let me source this thing. So you copy this particular folder location where it is present by sample breakpoints.gdb. So I have sourced it, right? Now all the breakpoints are loaded and it is currently assigned to the respective line numbers that I mentioned in that file. So if I'm typing info breakpoints, you'll be able to see this breakpoint set. Now when you run this program, the first breakpoint that is met is line number 22. So it is the third breakpoint that is set here, correct? So since in the program execution, line number 22 is the first thing that will come here. So the breakpoint 22 got executed, and then it now the program execution is stopped at line number 22. So either you can select to debug next, and then next and next like that, or else you can press continue to hit the next breakpoint, whatever the next breakpoint that you have set. Okay, so these are the few basic concepts to just get you started on the hands-on session of GDB. So going forward, we'll see some of the additional things also, like we'll go into the advanced concepts step by step to learn more and more hands-on on this debugging concept. Hope you have enjoyed this thing, and if you really like this thing, please subscribe to my channel, and then let me know what are the improvements that I can make. Thank you so much. Bye.